Good morning, class. Here's College Algebra, Chapter 2, Equations and Inequalities, Section 2.5, Quadratic Equations. So we've covered rectangular coordinate system, linear equations, models and applications, complex numbers, and now quadratic equations. The objective would be to solve quadratic equations by factoring, square root property, completing the square, quadratic formula. Reminding you of the distance formula, d is square root of x squared minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. The midpoint x sub 1 plus x sub 2 divided by 2 and y sub 1 plus y sub 2 divided by 2. Proportion a over b equals c over d. The slope rise over run y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Various equations of lines, standard form ax plus by equals c, slope intercept form y equals mx plus b, and point slope y minus y1 is m times x minus x sub 1. A vertical line has an equation of x equals a, m is undefined, x intercept at a0, and horizontal line y equals b, m equals 0, y intercept at 0b. Parallel lines have equal slopes, and perpendicular lines have slopes that are negative reciprocal of each other. When we look at complex numbers are in the form of a plus bi, their conjugate is a minus bi. The imaginary unit I is square root of negative 1, and square root of negative n is I times square root of n. When we look at powers of I is square root of negative 1, therefore I squared is negative 1, I cubed is negative I, and I to the power of 4 is 1. And remember, the easy way out would be to divide the exponent by 4 and keep the remainder. We will look at quadratic equations. First and foremost, everybody remembers all of these, exponential rules, such as a to the power of 0 is 1, a to the power of m times a to the power of n is a to the power of m plus n, the product rule, the power rule, the negative exponential rule, a to the power of minus n is 1 over a to the power of n, and so forth. I hope everybody remembers them. Also, the special products, a plus b quantity squared. When you FOIL it as a plus b times a plus b, you get a squared plus 2ab plus b squared. A minus b squared is a minus b times a minus b becomes a squared minus 2ab plus b squared. And these are conjugates, a plus b times a minus b are a squared minus b squared. Extremely important to know them because mainly the reverse process, which is factoring, is going to be a piece of cake. Otherwise, it's going to be difficult. All right. Factoring a polynomial of 4 or more terms by taking common factors from groups of terms is called factoring by grouping. So what is factoring by grouping? Simply group them together. So what is the first step of any factoring? GCF, the greatest common factor, if there is any among all of those. Okay. So we're going to factor the GCF for all, and then factor the GCF from each. By that, in this one, I mean by each group when we group. Get two groups of two terms such that each group has the same binomial, standing for two terms, GCF, and then factor out the binomial GCF. What do we mean by that? Let's look at this very simple example. So the way you factor this by grouping is that you put the first two and the last two together. If it works, fine. If it doesn't, the first and third. If it doesn't, the first and fourth. So the way you do the grouping, you do it such that it works. It may or may not work when you do the first two. Okay, it's very important to understand that. Let's put these two together. Let's put these two together. Obviously, from here, we can get the x out. We get x plus 7. From here, we can get the 3 out. We get the same thing. Remember what we are looking for. We are looking to get the same thing, namely x plus 7. And so all you have to do, write x plus 7, and then whatever is left from here is x, from here is plus 3. This is factor by grouping, everybody. Factor by grouping. That's all there is to it. Let's do the same thing. Let's do the first two and the last two, see if it works. What can we take out from here? X squared. So x squared times x minus 5. What can we take out from here? 2. What matters is that this piece must be the same, and they are. So the answer is x minus 5 times, what is left from here? X squared. What is left from here? 2. Let's do this one. Again, let's try the first two and the last two. Again, sometimes it doesn't work in that manner. So if we do that, from here, x comes out. X is in common. From the last two pieces, minus 5 is in common. So if I take the x out, I get x squared plus 2. If I take the negative 5 out, I get x squared plus 2. Remember, these two must be identical, and they are. So it's important to have this one the same as this one. So the answer is what's in common, which is x squared plus 2. From the first piece, we get the x out. From the last piece, negative 5, and we are good to go. All right. Now, what about factoring trinomials of the form x squared plus bx plus c? Again, as always, what is the first step? GCF. Is there a common factor? Take it out. Then what do we do then? Factoring is reverse process of multiplication. We know, for example, if we want to multiply these two, here's how we do it fast, because we are supposed to do the foiling in our head. X and x gives you x squared. 3 and x, 3 and 8, the product is 24. And then you say 3 plus 8, 11x. That's how you find the middle term. 3 plus 8 is 11. Therefore, you already know if you want to factor this is x plus 3 times x plus 8. So how do we find the positive 3 and positive 8? We look at 24, okay. We say we want to find two numbers such that the product is 24, namely C, and the sum is 11, namely B. So we want to find two numbers. The product is C, the sum is B, and the result is simply x times the first one and then x times the second one in this manner. All right. So you look for two numbers to do the job. Let's drill. Let's look at a couple of examples quickly. In this case, obviously, the first step would be to take out the common factor of 3x squared. Again, everybody has access to these PowerPoints, right? So clearly, what's in common? 3x squared. So I take out the 3x squared. This gives me x squared. This one gives me minus 2x minus 24. Here's the C. I want two numbers. When I multiply them, I get C, which is negative 24. When I add them up, I get B, which is negative 2. Can anybody give us those two numbers?
Four.
I'm sorry, I couldn't hear you.
-6 and 4.
Perfect. Perfect. And we're done. Needless to say, the beauty of math is you can check. So if you multiply them, multiply these two, you must get the one in the parentheses. Here's the next one, and hopefully everybody can clearly see number 2 is in common, so we can take out the 2. We get a squared minus 6a minus 16. Here's C. Here's B. We want two numbers. The product is negative 16 or C. The sum is negative 6. What comes to mind?
Eight and 2.
Say it again, please.
-8 and 2.
Perfect. And by the way, if you, just in case, if you're under the assumption is positive 8 and negative, so you can, it's a trial and error, and you can see it doesn't work. Can anybody tell us what's in common here? What is the GCF? GCF.
Three.
The GCF is a 2z cubed. So this results in z squared plus 8z plus 15. So we want two numbers. The product is 15 and the sum is 8. So clearly those are 3 and 5. So 2z cubed, z plus 3, z plus 5, the product of all of those. What happens if we have two variables in the following manner? We have a squared minus ab minus 20 b squared. In order to make it similar to this, I'm going to get started and write as follows. This is a squared, this is b squared. Therefore, we need to write it in this fashion. A plus something times b and a plus something times b. Now it's identical to what we did there, meaning c is negative 20, b is negative 1. We want two numbers. The product is negative 20. The sum is a negative 1. What numbers come to mind?
4.
One more time.
-5 and 4.
Beautiful. Negative 5 and 4. So put them in there. Negative 5 and 4. And that's the idea. It's very straightforward, everybody. Okay. It's very straightforward. Just be careful. Because it has b squared, there's nothing to worry about. So when it comes to this case, again, the same thing. You need the x and you need the y because it's y squared. So if we were to think about what we need, c is negative 15. B is -2. So we want two numbers. The product is -15 and the sum is -2. What are those? -5, +3. -5, +3. And because this is y squared, not only we need the numbers -5 and +3, we also need the y. And that's what I mean. So if you have two variables, not a big deal. You can follow it in the same manner, and it works out just as good. All right, we want to factor 2x squared plus 9x plus 4. There are different methods such as a trial and error. Okay. So there is no GCF. There is nothing in common. If there is, the first step is to take out the common factor. A is 2. A is no longer 1. And 2 is a prime number. Therefore, we must have a 1x and 2x. But what goes in there, it depends. So we are going to write factors of 4, right? 4. 1 times 4, 2 times 2, 4 times 1. And we plug in 1 and 4 here, 2 and 2 here, 4 and 1 here. What matters, we need the middle term. How do we get the middle term? See, these two, I want to make sure that we understand. Here's how we get the middle term. The product of these two is x. The product of these two is 8x. And they must add up to 9x. And the only one that does that is this combo. And therefore, that's the answer. Again, this is a trial and error. If you are comfortable with numbers, it works out. So you put factors of 4. You put possible factors of trinomials. And then sum of the products of the inner and outer terms, meaning we are interested in the middle term. Those two are easy to get. We are interested to make sure 9x works, because regardless of where you put the 1 and 4, the first term and the last term work. Here's grouping. A is 2, B is 9, C is 4. A is 2, B is 9, C is 4, because in general, we're going to write it as the format. Let me just write it underneath. A x squared plus bx plus c. Now, what do we want? Find two numbers such that, remember previously we said the product was c, the product must be a times c. The reason we didn't say a times c previously, because a was 1. So it wouldn't make any difference. Because a is 2, some number other than 1 now, it makes a difference. So we want two numbers. The product is AC and the sum is B. Okay. Now AC is 2 times 4, making it 8. So AC for us is 8. Factors of AC equals 8 is 1 and 8, 2 and 4. Okay. We want the sum to be B, which is 9. So obviously this is 9, this is 6. So the first one works. Again, I'm going over the methodology that you should have seen in elementary algebra, intermediate algebra. So what we are going to do, that's the first step. The second step is to rewrite bx. This is bx using these numbers. So that means we are going to write 9x as the sum of 1x and 8x. 1x and 8x. Do you put the 8x here, 1x here, or vice versa? Makes no difference. Both of them will work. And now you do factor by grouping, which means put these two together. You take the x out, x times 2x plus 1. You put these two together, 4 times 2x plus 1. So the next step is factor by grouping. So 2x plus 1 is in common, times x plus 4. And that's exactly what we got here. So many times you can do it by the trial and error. If not, you can do it by grouping. Two x squared plus 15x plus 7. Again, you can do by any of those methods that were explained. I'm going to give you the third method. Okay, you won't find it in, maybe you find it in some old text. So if you pay attention, this may be the easiest. So the format that I'm going to use, ax squared plus bx plus c, I put ax, and a down here in this format. So you have a fraction bar, ax, a. Now I follow what we learned from the grouping part. We write a is 2, b is 15, and c is 7. So we write this because a is 2 as 2x and 2x and 2. We need two numbers such that their product is AC, as you know, it's 2 times 7 or 14, and their sum is B or 15. We've seen that in the previous case when we did the grouping, and the numbers are 1 and 14. Now, previously, we would cut this into two pieces, 1x and 14x, and we go with the grouping. Now we don't need to. Just plug in 1 and 14 anywhere you want because both of them are 2x. Now, the denominator must go away. If it doesn't, you've made a mistake somewhere. As you can see right here, I can take the common factor of 2. I get x plus 7. These 2 cancels out these 2. And the answer is 2x plus 1 times x plus 7 in any order. This is probably the fastest one. I'll go over more examples, and then you decide what method to do. As long as you can factor them in any method, you are in good shape, everybody. All right, 5x squared plus 19x minus 4. Here's A, here's B, here's C. AC is 5 times negative 4, negative 20, and the numbers that you need are 20 and negative 1. I want to make sure we understand what happens here. 5 times negative 4 is negative 20. We want two numbers. The product is negative 20, and the sum is positive 19. So 19x, again, by the grouping, 19x would be 20x minus x. So 19x is cut into two pieces. And now, because it's cut into two pieces, we have 4 terms. We can do it by grouping. Let me erase this. So we're going to put these two together. Take out the 5x, we get x plus 4. And this one, all you have to do, take out negative sign. But I want to make sure we understand what we are doing. So I'm going to put negative 1. So the result is x plus 4 times what is left here, which is 5x, and what is left here, which is minus 1 in any order. All right. If I were to go with that method, I would go with 5x minus 1 and 5x plus 20. In other words, I would put the 5x, 5x, 5, and these two numbers, minus 1 and 20, put them anywhere you want. So with this method, we still need this, okay? Then we throw in negative 1 and 20. Clearly, you can see from the last piece, we can take out the common factor of 5. If we drop the common factor of 5, what happens? We get the same thing that we had here. In any order, okay? For example, if you end up having x plus 4 times 5 minus 5x minus 1 is the same thing. So this, I don't want to rewrite it, is the same as this. Over here, obviously, the first step is the GCF, and I hope you recognize that number 2 is in common, so it's x squared. So we take out 2x squared. This gives us 6x squared. This gives us 7x minus 3. Now, in this case, okay, obviously 2x squared will carry. In this case, here's A, here's B, C, negative 3. So the product of AC is negative 18. So AC is negative 18. We want two numbers. The product is AC, which is negative 18. And the sum is B, which is positive 7. The answer, negative 2 and positive 9. So we are going to cut the 7x into two pieces, minus 2x plus 9x, if we were to do it by grouping. Now, these two and these two, we factor them in the following manner. This one remains. Between these two, 2x is in common, so 3x minus 1. Between these two, number 3 is in common, and again, 3x minus 1. So inside the brackets, we get 3x minus 1 times 2x plus 3, and this remains. We are done. Again, I want to quickly show you the method that I mentioned. I think when you find, so when you find this, you don't have to go through this process. So ignore this process. What would you put here? A is, remember, we are dealing with this one, right? Let me clean up the mess. I want to make sure that we understand what we are dealing with here. So I'm talking about this. I got this, and I got this, and completely ignore this part. And I want to go with that. So A is 6, 6, 6. What do I put here? Negative 2 and 9. Where do I put it? Who cares? Negative 2 here, 9 here, or vice versa. The reason it makes no difference, because both of them have 6, 6. So take a look. We get this one. Now what happens from the first one, I can factor out the 2, and I get 3x minus 1. From the second one, I can factor out the 3, and I get 2x plus 3. And I hope you recognize 2 times 3 is 6. They cancel each other. So what do I get? I get exactly what I have here. This part. Okay. Which is, again, order is not important, although the order is in 3x minus 1 times 2x plus 3. In other words, I didn't write this, but this ends up being 3x minus 1 times 2x plus 3. So again, you may find this nice and easy. You're more than welcome to use it. It's up to you, okay? As far as factoring is concerned, any method will do the job. All right, we want to factor 12x to the power of 4 plus 14x cubed minus 6x squared. The very first step, as always, is GCF. So what do we find in common? Can anybody tell me what is the GCF here?
2x squared.
2x squared. So when you take out the 2x squared, this gives you 6x squared. This gives you 7x. This gives you negative 3. Negative 3. Very straightforward. So we are concerned with this part. This is done. And in this case, A is 6, B is 7, C is negative 3. So this part we are going to work on. And I'm going to write this. I'm going to write this, everybody. And therefore, I'm going to use 6. So I'm going to go with the method that I just mentioned to you, this last method. I want to show you how easy you can come up with the answer. We want two numbers such that the product is AC. 6 times negative 3 is minus 18. This is minus 18. And the sum B equals 7. So we want those two numbers. What are those two numbers? Anybody? What comes to mind? Two numbers, the product is negative 18, the sum is 7. So just write factors of 18, and one of them must be negative. Okay? Let me just quickly show you something. This is important, class. So you look at 18 and you say 1 times 18, 2 times 9, 3 times 6. And I put a negative sign here, meaning one of them must be negative. Okay? You follow what I'm saying? Such that the sum is 7, and that would be negative 2 and 9. So throw in negative 2 and 9 anywhere you want, here or here, in any order you want. So again, the first one, I can take the 2 out. And the second one, I can take the 3 out. The product of these two is 6. And I wanted to do this. We did this in the previous page, but I wanted to do this in a manner that becomes clear, that it's fairly easier than the rest of them. So I repeated that for you. This was, I think, extremely important to see. Okay. All right. So we get this one, right? Solving quadratic equations by completing the square. A quadratic equation is an equation of the form ax squared plus bx plus c equal to 0, where a, b, and c are real numbers, and a cannot be 0. A square root property or principle says if x squared is a, where a is a real number, then x is plus minus square root of a. For example, x squared equals 49, x is plus minus 7. So that's pretty straightforward, okay? That's pretty straightforward, everybody. This is one of those principles, okay? X squared minus 9 is 0, so we're going to use the square root property. By the way, whether they say what property to use or not, if they ask you to solve, you always go with the easiest possible method. In this case, even if they don't say that, quickly you move the negative 9, make it positive 9, and x is plus minus square root of 9 or plus minus 3. Same thing here, you move the 10, that means you are going to subtract it from 85. You get 75. So x is plus minus square root of 75. Now, 75 is the product of 25 and 3. 25 comes out as a 5, 3 remains, plus minus 5 square root of 3. All right, we want to do this. 16x squared plus 9 equal to 0. We're going to move the 9. And we're going to divide by 16. And x is plus minus the square root of negative 9 over 16. The animation wasn't in order. So plus minus 3 over 4. I want to make sure we understand why this is the case. This is the product of negative 1 under the radical, which will go and exchange itself to I. 9 over 16 comes out as 3/4. Remember, when you have a negative under the radical, you got to move it. Okay? And you're going to get rid of it. And if it's a square root, you change it with I. Continuing with the same concept, we want to solve this equation, part A, 5x minus 3 quantity squared equals 4. In an equation in the form of ax plus b quantity squared equals c, notice that the expression of ax plus b is squared. We can use the square root principle to eliminate the square, meaning take a root of this one, take a root of this one. This, since it's a variable, you keep it the way it is, and this one plus minus square root of 4. And everybody knows plus minus square root of 4 means plus minus 2. Move the negative 3, make it positive 3 on the right, and divide by 5. 3 plus 2, 5 over 5 is 1. And 3 minus 2 over 5 is 1 over 5. So there are two answers. 4x minus 1 quantity squared equals 15. We do the same thing. 4x minus 1 is plus minus the square root of 15. This is using the square root property. And moving the negative 1 on the right side becomes positive 1. Divide by 4, and that's your final answer. That's the final answer, everybody. Now, we're going to solve quadratic equations by completing this square. Ax squared plus bx plus c equals 0. A perfect square trinomial is a trinomial that can be expressed as the square of binomials. For example, x squared minus 10x plus 25, everybody knows is x minus 5 squared. A squared plus 8a plus 16 is a plus 4 quantity squared. Note that in every perfect square trinomial, the constant term, this number, is the square of 1/2 the coefficient of the x term, or minus b over 2a to the power of square. So basically, whatever this one is divided by 2, you don't have to have it. It doesn't matter you have a minus or plus, okay? But basically, Divide this by 2, you get -5. Square it, you get positive 25. Divide this number by 2, you get 4. Square it, you get positive 16. Okay? So this is just b, not minus b over 2a. So the step is number 1, find b. Number 2, divide b by 2. Number 3, square this number. And that's the constant that we are referring to. So for this example, solve x squared plus 6x plus 5 equals 0. Let's write the steps here. Okay, we are going to move this to the right. So move the constant to the right. So write as x squared plus bx equals c. Add b over 2 quantity squared to both sides. Write it as x plus b over 2 quantity squared, which is c plus b over 2 quantity squared, and simplify. Solve by the square root principle. So rather than just reading this, let's find out how we actually work it out. So number 1, move the 5, move the constant, we make a -5. Number 2, what is the value of b? 6. Divided by 2, 3. Square it, 9. Now let's add 9 to both sides. When we do that, the left side will always be the variable. It doesn't have to be x, but this is x. So the variable in this case, x, plus b over 2, including the sign. In other words, this is positive 3. So positive 3. If it's negative 3, it's negative 3. So the variable mostly is x, and b over 2 to the second power, and the right side, they add up to 4. So you have the variable x, and then b over 2, including its sign. B over 2, including its sign, is here. And now, using the square root principle, x plus 3 is plus minus square root of 4 or plus minus 2. Move the 3. And negative 3 plus 2 becomes -1. Negative 3 minus 2 becomes -5. And those are the answers, everybody. All right, we are going to move on. In this example, we want to solve by completing the square. X squared plus 10x minus 16 equal to 0. Number 1, we are moving the -16, and we make it positive 16 on the right. Now let's do the work. So b is 10. We divide it by 2, we get 5. We square it, we get 25. Let's add 25 to both sides. So we are adding 25. Now, left side is the variable. Whatever the variable is, the variable happened to be x, and b over 2, including the sign. So plus 5 quantity squared, and the right side, 16 and 25, they add up to 41. So x plus 5 is plus minus square root of 41, and move the 5 becomes x equals -5 plus minus the square root of 41. Pretty straightforward, everybody. Let's look at this case. First, move the 9 and you get 4. So let me write that actually. X squared minus 12x equals 4. Now, b is negative 12 divided by 2, negative 6. Square that, positive 36. So we are going to add positive 36 here and here. So we add 36 to both sides. This becomes 40. This becomes the same variable, which happened to be x, and b over 2, everybody. b over 2 happened to be minus 6. So x minus 6 quantity squared, the right side is 40. So x minus 6 is plus minus square root of 40. We move the negative 6. And the only change I need to make is to write 40 as a 4 times 10. So it comes out, 4 comes out as 2 square root of 10. So we have 6 plus minus 2 square root of 10. We're going to continue solve by completing this square, everybody. First and foremost, we're going to move things around. That means we're going to move the negative 9 to the right, 10x to the left. And then we want a to be 1. We divide everything by a. Everything by a. So we're going to divide everything by 2. You can put a fraction bar and 2. That means this is x squared, this is minus 5x, and this is 9 halves. So b is negative 5. Divided by 2 is negative 5 halves. And square it, you get 25 over 4. We're going to add 25 over 4 to both sides. This is what we've added. Now the result is the left side, everybody, is the variable, which is x, and b over 2. b over 2 is negative 5 halves, quantity squared. The right side, we want to add this to 9 halves is 18 fourths. We add it to this, we get 43 over 4. So we just take a common denominator. So x minus 5 halves is plus minus the square root of 43 over 4. And we should know this is, let me use a different color. This is plus minus square root of 43 over square root of 4 is 2. So if I move this to the other side, they have the same denominator, namely 2. So x is 5 plus minus the square root of 43 over 2. Well, we don't have to move anything around. It is in the format we want, except we don't like the 9. We're going to divide both sides by a, namely 9. So this becomes x squared. This becomes minus 4x. This becomes minus 37 over 9. Divide everything by a. Here's the b. B divided by 2 is -2, and when we square it, we get +4. Let's add +4 to both sides. Left side is the variable, again, x, and b over 2, which is -2, quantity squared. The right side, 4 times 9, 36, and -37 is -1 over 9. I'm assuming nobody has any problem adding up numbers. So 4 times 9, 36, with -37 is -1 over 9. So x minus 2 is plus minus the square root of -1 over 9, which is plus minus 1/3 I, because 1 over 9 comes out as 1/3, and a negative sign changes to I. We move the negative, and this is the final answer. Here's an interesting application. Example number 12. When a triangle is inscribed in a circle and the diameter of the circle is one side of a triangle. So here's a circle, and here's the diameter, which is one side of a triangle. A right triangle is formed. An isosceles triangle, meaning two sides are equal, is inscribed in a circle of radius 20 feet. So class, if the radius is 20 feet, we want to find the length of each side. The diameter is 40. So let me just actually show you that one. So this says R is 20 feet. And so that means D must be 40, because D is 2 times R, okay? Now, as you know, according to Pythagorean theorem, a squared plus b squared equals c squared. Here's the a, here's the b, here's the c, where both sides a and b are the same. We can call them x and x, or a and a. And the c, we're going to call it d actually, or just simply we know this side is 2 times r, which is 40. Okay, so according to this formula, okay? So x squared and x squared. So let's actually erase something here. So x 40, okay? Remember I said this is r equals 20, okay? The whole thing is 40. So x squared and x squared, they add up to 4d squared. That means 2x squared is 1600. That means x squared is 800. And that means x is plus minus the square root of 800. And 800 is the product of 400 and 2. 400 comes out as 20. 2 remains. Just a precise answer, by the way. Sides can't be negative, so we only keep the positive 20 square root of 2, which is almost 28.28 feet.